compound angle formulas. These are the formulas. Now, you might look at it and go, wow, that is a lot to memorize. It's actually not that bad. They match in terms of how they're written. So when you look at this formula, I know that sine of A plus B, so look here, this is A, so I'll use green for A, and I'll use a pink for B. Okay? It matches here, so with the way they write the formula is very nice because they match it. So this is A, right? So A, and then B is here, B, B. So you can see all the formulas are written in that same order. So angle A plus B is sine of AB cos AB, right? So it's going to be first angle, second angle, first angle, second angle. They do that for all of them. So it's A minus B. Look, it's sine A cos B cos A sine B. So that's why it's written in the order that it is, because then look, cos of A plus B is cos A B sine A B. Same here. You'll notice, look, the sine addition formula and the sine subtraction formula, the only difference in the formula is the plus or the minus in between. When I give you a plus here, it's a plus here. When I give you the minus here, it's a minus here. The way I memorize the sine one is that it keeps the sign in the middle. Do you have to memorize it? No, you don't. But you should recognize it. So if I gave to you, for instance, I'll use kind of a silly example. I said a squared plus b squared. What does that remind you of? A squared plus b squared, right away, yeah. Pythagorean theorem. So if I give you the left side of an equation, right, so c squared equals, if I give you this and you go, oh, I think that's Pythagorean theorem, reminds me of that. That's what we're going to do with this, is that sometimes I'll give you the right side. If you look at it and go, I don't know what that is, and you have to look at your sheet of formulas and have to keep matching it, it's going to take you longer. You should go, oh, wait, sine, cos, cosine, I think that's the sine formula? Yeah, it is. And then you go to the, you know which box. Because remember, we're giving you this whole sheet, but you have to know to go to this box to look for it. If you're starting at the top of the box every time and going, I don't know, you're wasting your time, plus you're not learning that much, right? So you should go sine, cos, cosine, sine, cos, oh, I think that's the addition sine formula, and then you go look. And it'll help you out because the formulas will be there, but you should almost have it memorized yourself. Like honestly, by the end of today's lesson, you'll have this pretty much memorized. Okay, and again, it's there just in case you go, wait, was it a minus or a plus? But the way I remember sine is that, look, it keeps the same sign. Cos has the opposite sign. Cos, if it's plus, it's a minus in between. If it's a minus, it's a plus in between. So I go, oh, sine keeps the sign, cos switches the sign. Cos formula goes cos, cos, sine, sine. So it goes cos A sine B, sine A sine B, right? And it always goes in order. Do you see what I mean by order, right? It goes A, B, A, B, A, B, A, B, A, B. So it's nice how they made the formulas match, and they wrote it in the order so it goes A, B, A, B. So you'll see when I use it, I kind of memorize it the way it's in order. And then it goes cos, cos, sine, sine. And look, same formula, cos, cos, sine, sine. And the only difference is the sign in between. Look, this one's a plus, so it's a minus. This one's a minus, so it's a plus, right? It's cos, cosine, sine. You're practically going to memorize those two by the end of the lesson. Okay. Tan is a little bit harder to memorize in terms of just memorizing it in general, right? But tan, I always remember that tan is actually made up of sine over cos. So the way they developed this formula is that they put the sine over the cos, and then they simplified it. So sine over the cos, I won't show you how they simplify it because we're giving you the formula sheet, but before we used to make the students memorize these, and we gave you no formulas. So I would show you how to develop tan from the sine and the cos, because you would sometimes have to do that if you forgot to memorize tan, right? I won't do that, but the way I remember it is that keep the sign. So again, look, the plus keeps the plus, and the bottom is the minus, because it's like it's following the sine and the cos. Keep the sign, opposite sign. Keep the sign, opposite sign. Here it's addition, and there it's subtraction of the same two angles. Again, I don't find that hard to memorize. Like in terms of formulas to memorize, it isn't bad. Once I look at it once, I go, oh yeah, I've got it. You won't have to, but if you needed to or want to, it's not a bad set of formulas to memorize. So now, I'll show you why we need these formulas and why they're super cool. in a second. Let me just remind you of rationalizing the denominator first. So we need this. There's going to be a bunch of radical work that you're going to have to do. So half the question or 2/3 of the question is just going to be lowest common denominator, add and subtract, put it over, rationalize, and then bring it together. So the first part will be the trig using the formula, and then the next part will be just radical work. Right, so you'll see. But let me just remind you, when I have a radical and it's got a one term here on the bottom, I only multiply it by the root 5, right? Only the root 5, not 2 root 5. You're wasting your time if you multiply by 2 root 5. You'll get the same answer, but you're doubling your work. So it's just like people who go, oh, I don't like to use the lowest common denominator when I do my rational expressions. That's ridiculous because now you've doubled your work. So where I would take 3 steps, you're taking 6. So do not do 2 root 5. Will you lose marks? Yes, you will, because you're doing it in the worst way possible. So only root 5, not 2 root 5. When I do this, I'm going to get 3 root 5 over 2 root 5 times root 5. Root 5 times root 5 is 5. Do you have to show me this step? No, you don't. You can go straight to 3 root 5 over 10. So last year we were like, oh, make sure you show everything. No, if you can do the 2 and the 5 in one go, you can go right there. Okay, move that up. Okay, so that's if you have a single term on the bottom. You only multiply by the root 5. Here, you're going to multiply by what we called last year the conjugate. Right? You don't have to remember the word conjugate, but sometimes someone may say, should I multiply by the conjugate? It's nice to know what they're talking about. So the conjugate, okay, and again, you don't have to know that word. We won't use it kind of in problems, but someone might use it in context. So 2 plus root 3. So we had to keep the opposite sign. So this sign here we changed it the opposite. Why did we do that? We did that because it made it the difference of squares in the denominator. So that made the difference of squares in the denominator, right? So difference of squares in the denominator, right there. So 2 times 2 was 4, minus, and the middle term canceled out, root 3 was just the 3. Right, so it made a difference of squares in the denominator. That gets rid of the radical in the denominator. Do you have to know how to rationalize? Yes, you do. Okay, then on the top, we were going to do 1, 2. So yes, you have to do distributive, so that would be 8 plus 4 root 3. Do you leave it like that? No, you don't. You go 8 plus 4 root 3. This is over 1. Do you leave it like that? And could you skip the step? Yes, you could. You could have gone straight to 8 plus 4 root 3. No, over 1. So a lot of these questions are going to require radical work, where we're doing rationalizing, we're collecting like terms, we're multiplying, distributive. Now, how do we use the addition subtraction formulas? So this beautiful box here of the addition subtraction formulas. Why is this relevant and how do we use it? This is really fun because it gives us more possible exact answers. So you'll see the first question I said here, determine the exact value. In the past, when I said exact, the only numbers that we could use that were exact were 30. So I'll remind you here. So 30, 45, and 60. Right? So that's what we're thinking in our heads. We're going exact means that. 30, 45, and 60. Sorry. And 60 degrees. Right? So every time we did exact, it was always those numbers there. So we had a lot of 30s, 45s, and 60s. By learning this formula, by learning this addition subtraction formula, I can now do any combination of the 30, 45, and 60. So if I say to get cos of 15 exactly, you go, I can't do that. It's not one of my nice, precious, beautiful angles. But yes, it is. It's a combination of two of them. So what combination will get me 15? What combination will get me 15? 60 minus 45, or 45 minus 30. So I'll do both, or can I do any others to get me 15? No. Okay, so those look good. Either one of them is perfect and wonderful. You'll get the same answer as long as you rationalize. So as long as we all rationalize and get the same answer, we will get the same form of the answer at the end, right? Because otherwise sometimes we'll have different forms. So we rationalize the denominator. Both of these answers will be exactly the same. Okay, you get to choose whichever one you want to do, and we're going to use this. So this 15 is a combination. So that means that any combination using 30, 45, and 60 is fair game now. Before I had to only use 30, 45s, and 60s, right? And those were my related acute angles. That was the only one I could do. But now I can do any combination of that. So that means I could do 105, right? 45 plus 60. I could do 75. I can do 45 minus 60, negative 15. I can do, what else can I do? I'm running out. 90, but we already know how to do 90. I'll show you 90 later. But yes, there you go. Okay? So that's why this is so nice. It's because it broadens our exact value answers. Because before we could only do 30, 45, and 60. But now we can do any combination of those. Right? So 75, 15, 105, yeah. Good? All right. So let's use the formula. So this is cos. The way I remember cos is cos, sine, sine. You sound like a crazy person memorizing it. Cos, sine. We were never given these formulas before. We always had to memorize. We're giving you them just because we just become too kind. I don't know what's happened, but I was never given a formula. So you would sit there memorizing it, and you would be going cos, sine, sine, and sine is sine, cos, sine. Right? And you sound like you're like, what? I'm sorry, what? Cos, sine, sine, and sine, cos, sine. It's cos, sine, sine is the cos one, and sine, cos, sine is the other one. And the sine in the middle, I always remembered sine keeps the sign, cos is the opposite. So here, the way I go is that, and again, it always goes in order. So I'll show you how I write it. I do this. I do cos, and then sine, sine. I'm going to use, both of these will work. I'm just going to do this one. So I'm going to keep this to the side. I'm going to do this one, right? So I go cos, sine, sine. The angles, like I said, it matches. So 45, 30. So I love how they did the formulas because it matches. This is first, this is second. The sign in the middle is, if this is minus, this becomes plus in the middle. So cos, sine, sine. You don't have to memorize it. I'm just giving it to you because you want to be able to recognize it. If I give you the backwards formula, cos, sine, sine, you'd be like, oh, I think that's the cos one. And then you can refer to your sheet, right? But you can't just go blind into it saying, I have no idea which formula is which. Okay, so sine, and again, look, the order is in order. So the way they wrote the formula, it goes 45, 30, 45, 30, which matches the AB here. So that's AB, AB. And then we're just going to go ahead and answer it. I'm going to draw my special triangles here on the side. You don't have to unless we ask you to, but I'm going to just draw them here so I have them for reference. So this is 30, 60. So this will be 1, 2, root 3. And then again, 45. And that would get me 1, 1, root 2. Okay, so cos of 45 is 1 over root 2. If you want, you can memorize that rationalize, so go root 2 over 2, right? So it's up to you if you want to do that. I'm just going to go 1 over root 2. Most students do that. Cos of 30, so cos of 30 is root 3 over 2. Root 3 over 2. Plus sine of 45, 1 over root 2 again. And sine of 30 is 1/2. Again, we're just going to our triangles. And that's it. That's the only new thing I had to teach you. The rest of it is just do radical work. So we practice all this radical stuff when we did radicals in grade 11, right? You do order of operations, multiply, all that sort of stuff. So this is exactly, and we did this in grade 11 as well. So the only new thing I had to teach you was to go from the cos of 15 to the formula, right? And we did this form. They're currently doing that in grade 11 now. They're doing something like this where we simplify that. So we're just going to go ahead and simplify. Order of operations, so numerator times numerator, denominator times denominator. And this order may vary. So the order that you simplify it in might vary a little bit. I'm going to do root 3 over 2 root 2 plus 1 over 2 root 2. You can gather them together and then do rationalizing, or you can rationalize and then gather them together. Up to you, right? So the order here doesn't matter. I'm going to rationalize, so it'll be root 2. I'll do both like that. And then in the denominator, they're both going to be the same, right? So what's the denominator going to be? 2 times root 2 root 2. Root 2 is 2 times 2, so I'm going to get on the bottom denominator 4, right? Is that okay if I do that in one go? So you don't have to show me 2 times 2 to get me the 4. You can if you want, but again, grade 11, I'm like, show me everything. In grade 12, I'm saying, yes, you can skip some steps. So you go 2 times 2, so it'll be 4. Then root 3 times root 2 is root 6, plus 1 times root 2 is root 2. Can I do any more? Nope. All done, right? That's it. Beautiful, gorgeous. That's lovely. And that's why you can't use the other calculators, because the other calculators will go from here to your answer for you fully rationalized. So they're like, can I just have it with me so you can check your answers? No, it's still not fair. That's why the university started going, wait, you should see one we did, and the other, we'll see it down here, and there's like 8 steps we did. So you can imagine having that, and you're like, oh, but I want to just check my answer. And I'm like, a little unfair. That's why the university kids who came back to visit were like, we're not allowed to use these. I'm like, makes sense. Okay, so let's try it again. Radians. Oh, you thought we were leaving radians. No, we're not. So we're going to go back and forth between degrees and radians. I just take this guy and I convert it. So you know how to convert it. So if you picture it better in degrees, then let's just picture it better in degrees for a second and convert it back and forth. So in this question here, can you do 5 times 180 divided by 12 for me? How much do we get? So this is tan of 5 times 180. So that's 5 times 180, right, divided by 12. So you do that on the side. You don't have to show me. That will get you tan of, what do we get? 75, right? Okay, 75. You don't have to show me this. You do not have to show me this. You can go straight to, I want you to convert it back to radians. So usually when a teacher gives you something in radians, they want you to answer in radians. I don't mind if you do a conversion to degrees so you can picture better. You don't even have to show me that. Then you can go tan of 75, use my special angles, pi over 4, so 45 plus 30, so pi over 4 plus pi over 6. Good? You're going to do this so many times, you're going to be so bored of these special triangles. Right? Over and over again. But it's showing you a nice application. So it's nice because now we can expand how many exact answers we can do. Any combination of 30s, 45s, and 60s. Right? And then now we just use the formula. So we're going to break it down. So the formula is tan of each one. So I always picture it's like it's distributive. So tan of 4 plus tan of 6. And then 1 minus. So I have it memorized. Again, you might refer to the sheet like that. Right, so refer to the formula sheet, and that's it. And now the rest of it is just calculating. So that's the only new thing I had to teach you. Everything else we know before, right? We're using the special triangles, we're simplifying, and we gave you questions like this in grade 11 where we had division, stuff like that, to simplify. Right, so the rest of it is just filling it in. I'm going to write it horizontally. I used to do that with the grade 11s, is that I would do all of the numerator. So I would do all of this numerator here, write it over here first. So I would do all of the numerator here, and then I do the denominator and put division. I just like to write it horizontally instead. Some teachers don't. I like to write it horizontally. So you don't have to. You can write it over, and then I would do the denominator here. Does that make sense? Right, you don't have to do this. I prefer not to write a fraction and a fraction. Right, so I would do tan. So tan of pi over 4 is tan of pi over 4, 1 over 1, which is just 1. Plus tan of pi over 6. So tan of pi over 6 is here. We know pi over 6 is 30. 1 over root 3. So plus 1 over root 3. Is that okay? And then here, 1 minus, and look, once you've done this, you're using the same two numbers, 1 minus 1 and 1 root 3. Tan of pi over 4 is 1, and tan of pi over 6 is 1 over root 3. So once you've done that, you actually have the same, same answers there. Right? If you choose to write it this way, the way I'm showing you, you have to put the bracket there. Because you're saying I'm choosing to put the denominator as one term, right, as one combination here, and then the other one here. So you have to put those in brackets. You have to put the brackets. Okay, so I'll note that down. So brackets. So if you choose to show the form like this, can you please put the brackets on it? Because you're doing numerator, denominator. It's an order of operations. All right. Now you have your choice. You can do lowest common, you can rationalize, then do lowest common. Completely up to you. What would you like to do first? Rationalize. What did I do with these guys? I rationalize first. Right? Some people do lowest common, then it's up to you. So I'm going to rationalize this guy first by going root 3. And I'll rationalize this one, root 3. Like that. And again, it doesn't matter the order as long as you rationalize at some point. So we're going to go 1 plus, and it's root 3 over 3 divided by 1. Oh, this is the one you better not write too big. We need another column of work. Oh, shoot. Okay, so don't write too big. So 1 minus, that multiplies, it'll be root 3 over 3. Yeah, we might have to squish another answer here. This is the one where we ended up being 1, 2, 3, 4, 5, 6, 7, 8, 10 steps. Okay, so we go, then I did, and you can combine a couple of these steps though, right? So some people go, well, I combine a couple, so it's over 1. So you'd have to do lowest common. That's over 1, lowest common. So I won't write too big. So this will be 3 plus root 3 over 3. Is that okay for the common denominator? Divided by, and this will be 3 minus root 3 over 3. Keep going. So look, now none of this is the new stuff that we learned, right? All of this is just radical work. So then division becomes multiplication. So 3 plus root 3 over 3 times, and then you flip it over, so 3 over 3 minus root 3. Right, so this had to switch. Right, so switch. Let me switch that to times. We're okay there. And now we are allowed to cancel when it's multiplication. Right, so we can cancel the 3 and the 3. They both go away and just become 1. Okay. I'm going to go equals 3 plus root 3 over 3 minus root 3. And are we done? I know, because you have to rationalize that denominator, which is why you're like, so we can use that other calculator? Nope. The 10 steps, yeah, you would have the answer to check with. So rationalize. So rationalize. We are not done. So you want to rationalize that by multiplying by the conjugate. So it'll be 3 plus root 3, 3 plus root 3. Then we're going to do equals. Are we ready? So equals, the denominator here is the difference of squares, like I showed you above. So 3 times 3 is 9, minus, and then 3. Right, the middle term goes away, difference of squares. The numerator, you have to do the whole FOIL. So it's going to be this whole thing, but also, if you notice, it is a binomial squared, right? So hopefully you notice that they're the same, so you don't have to do the full FOIL. So it's going to be the first one. So again, you can do the first whole FOIL, but it's a binomial squared. So hopefully you can do a little faster. So the top here would be, I'm going to just write it in green so you can see it, or no. So 9, right, plus 3 root 3 and 3 root 3. So hopefully you can go 6 root 3 faster. And then root 3, so that would be 3. Right? It's a binomial squared. So this is 3 plus root 3 squared. Right? So a little faster. We're not done. It's the never-ending question. Not done, not done. So now let's go. I'm going to squish it right up here. It should fit. We need like 3 or 4 more steps. So I'm going to drag this up. It's okay. So I'm going to drag this up here. Okay, so whenever you do this, make sure you do a nice line so I can follow your work. So you're going to say, okay, I'm going to drag it up here. So follow my eyes up here. We're going to go equals. 9 plus 3, 12, plus 6 root 3. Or you can do 6 root 3 plus 12. It doesn't matter the order. 9 minus 3, 6. Oh, just 2 more steps. 1 more step. Are you done? No, because what we taught you before again last year is this, right? If all the whole numbers can be simplified, you can factor out the 6 and cancel. But if you want to do it faster, you are allowed to cancel all of them as long as you're canceling all the whole numbers by the same amount. So I'll divide them all by 6. That'll do 2. So that gets me final answer. Final answer, I'll do it in pink, is going to be 2 plus 1 root 3. And we're done.